multiply a negative, and we get v equals -2 -98 e -5t minus 10, for t is equal or greater than 10. And that is the answer for D. Now let's go to E. It says find an expression for his height s above the ground for t is equal or greater than 10. I hope you remember the relationship between velocity and displacement. If you integrate the velocity function, you get the displacement function. So our velocity function we just got was v equals -2 -98 e -5t minus 10. That was the equation of v we just got. We just have to integrate that, which is in terms of t, which is written as such. And this is also fairly simple integration, but to understand a bit easier, I'll just show you how I like to do it. Just separate the components so that I only get one variable that has the unknown, since you can just expand it and bring out the exponential over here. So since we know this, we can just do a simple integration of the exponential, differentiate the function and bring it under and keep it up there. And this one is just a number of different integrations, so just add a variable. So this becomes -2t plus -98 e50 e -5t, but we had this, so we have a -1/5 here, since we differentiate and bring it under. And if I simplify this a bit, I get that's -2t plus 98/5 e to the power of -5 bracket t minus 10. And don't forget plus c again, because it's an indefinite integral. Now the part is to get c. How do we do that? Previously we were given that after 10 seconds of Richard's fall, he has already arrived 500 meters. So using that, we can just add in the values. Since the displacement is 500 meters from the initial position, we can show that 500 equals -2, the t was 10 seconds, 10 plus 98/5 e -5 times 0 plus c. This will in turn become 1 because it's the power of 0. And that is what we get. 500 equals -20 plus 98/5 plus c. And just move all these values, and then we get c equals 500.4. And that's our c value, and all we have to do is add this back to here. So our final answer will be this. -2t plus 98/5 times e to the power of -5 bracket t minus 10 and bracket plus 500.4. on to the next question, which is also the final question. Okay, this is a fairly simple question. It says, find the value of t when Richard lands on the ground. This is fairly simple since we just got our displacement function. So what we want our displacement to be is 0. Since the displacement from the ground is 0 since he's on the ground. So what we need is, okay, first let me write the displacement equation we had. S equals 98 over 5 e to the power of negative 5 t minus 10 minus 2t plus 500.4. Now we need that s equals 0 equals 98 over 5 e negative 5 t minus 10 negative 2t plus 500.4. Well, of course, you could try to do this by hand, but I will use a graphic calculator using the number solve application. And what we get as our final answer in the number solve application is that t equals 250.4, which can be simplified as 3 significant digits of 250 seconds. So in context, Richard fell down from the helicopter and in 10 seconds traveled 500 meters down, opened his parachute, and then it took him another 240 seconds to reach the ground safely. And that was my question. Thank you for listening and have a good day.